Hello, in this video we're going to learn about rational exponents and radicals. We've already touched on this a little bit earlier in the chapter, but we're going to get more specific here today. So we have this square root sign, and we call it a radical sign. The number that goes here is going to be the index, and so when there's no number there, there's no index, the degree is 2. So for instance, the square root of 16 is 4. But the index could be different. It could be a 3, which is a cube root, or a 4, which is a fourth root. And then the number in the under the square root sign, or the letter, or whatever, is called the radicand. So let's try a couple of these. So if we look when we're trying to find cube roots and fourth roots and fifth roots and stuff, it's actually pretty easy to do because the numbers get so large so quickly that there's only a few choices that we can make. So when we're trying to find the cube root of 125, I mean, you could start off with something like 4. So 4 times 4 is 16. 16 times 4 is too small, so 4 didn't work. So 5 times 5 is 25. 25 times 5 is 125. So we know that just through a little bit of trial and error that the cube root of 125 is 5, because 5 times 5 times 5 equals 125. Okay, now when we get to the fourth root, basically the larger the root is, the easier it is. Fourth root is 16. You could try something like 3, 3, 9, 27. We're already too big, so drop down to 2, 2, 4, 8, 16. So we know that the fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. Now there'll be times where you're asked to find a fourth root or something and it's not a whole number, in which case you would want to use a calculator for that. Alright, so here we have something we saw earlier in the chapter, which is a to the m over n power. And basically what that means is the m we know is the exponent, the power, right? Because when I say a to the m power, or 3 to the third power, it just means 3 times 3 times 3. So the m is easy, that's just the power. The n is actually the root, or the index of the root. Okay, so we can write a to the m over n as a to the nth root, and then brought to the m power. Okay, so here's an example of that. 8 to the 2/3 power is the same as 8 squared, right? So we're going to square it, but we have to take the cube root of it as well. So if we were to answer that, we would say, well, the cube root of 8 is 2, and so that just means 2 squared, which is 4. Okay. Next one, so converting to radical form. So radical form is, again, when we have this symbol, the radicand symbol, or sorry, the radical symbol. Notice the 3/5 only sees the x here. It does not affect the 16 at all. So the 16 is going to end up outside the radical. And then the top number is always the power, right? So we're going to raise that to the third power, and the bottom number is the index. So we could write it like this. Now the 3 can go with x only or with the whole thing. So you could also write it like this. You could also write it like that. Okay, and so simplified radical form. So before I get on to the next example that's in the book, I want to talk to you about simplified radical form. When we want to find the square root of 28, that's not going to be a whole number, so you'd have to use a calculator for that. But there's something called simplified radical form, where we use factors of 28 to get any whole numbers out of the radical that we can. So let me explain what I mean by that. So 28, if we make a factor tree, has factors of 2 and 2 and 7. So what I could do is I could say, well, this is the same thing as saying the square root of 2 times 2 times 7. And anytime I have a pair of numbers, like 2 and 2, I can break that off, And we all know the square root of 2 times 2, or the square root of 4, is 2. And so the simplified radical form of 28 would be 2 root 7. So if we were going to do the fourth root of 32, we'd first check if there is a fourth root of 32. So I would check maybe the number 2. 2, 4, 8, 16, 32. So the fifth root of 32 is 2, but the fourth root is not a whole number. So what we can do, again, is make our little factor tree here. So we got 16 times 2, 4 times 4 times 2, 2 times 2 times 2 times 2 times 2. Okay, so there's 5 2's there. 2, 2, 2, 2, 2. And since we're looking for the fourth root, instead of breaking them out 2 at a time like we did up here, because we were looking for a square root, now we need to break them out 4 at a time. So we have the square root of 2 times 2 times 2 times 2, and then another one. So we had 5, right? So here's 4 and 1. So the simplified radical form would be 2, which is the, whoops, I forgot to write the 4. That's important. So the fourth root of 4 2's is 1 2, or the fourth root of 16 is 2. And then there is no whole number fourth root of 2, so we just have to write it like that. So the simplified radical form of the fourth root of 32 is 2 times the fourth root of 2. Okay, so we're going to use this knowledge to do another example here. Here we have 64x to the 4/5 power. In this case, because of the parentheses, the 4/5 is going to affect each thing in here. So what we have is 64 to the 4/5 power times x to the 4/5 power. Now, the fifth root of 64, there is no whole number that is the fifth root of 64, because 64 is, I believe, 6 2, so 2, 4, 8, 16, 32, 64. Okay, so the fifth root, if we wanted to do simplified radical form, we could have 32, right? 2 times 2 times 2 times 2 times 2. So we can find the fifth root of that, right? But there's going to be that 2 left over. Okay, so what we're going to do is break that 64 into 32 to the 4/5 times 2 to the 4/5, right? Because we're able to bring out the 32, because we can find the fifth root of 32, which is 2. And then we have x to the 4/5. All right, so 32 to the 4/5 is same as 2 to the 4th, right? So that's 2 to the 4th times, and then these can be combined, so we can say 2x to the 4/5, right? And then 2 to the 4th is 2, 4, 8, 16 times 2x to the 4/5, and then we could just put that in radical form, so 16 times the fifth root of 2x to the 4th. So that would be a way you can write this in simplified radical form. So that one's pretty confusing, but with practice you'll be able to get it. All right, converting to exponential form. Again, that's like the fraction. So the 7, that's always going to go on top, right? Because y to the 7th power. And then the bottom of the fraction is always the index here. So that's actually not too bad. Here we have 27. The 5 is not affecting 27 because it only sees the d here. So what we have is 27 to the 1/3 power, or the cube root of 27 times d to the 5/3. Now the cube root of 27 is 3, so we can just say 3d to the thirds. All right, I think I have one more example for you. So here's a real application for square roots and whatnot. This formula r equals 73.3 times the fourth root of m to the third relates metabolic rate, which is r, measured in calories per day, to body mass, which is the m, measured in kilograms. So what is the metabolic rate of a dog with a body mass of 18 kilograms? So what I've done is I've just replaced the m with the 18, right? So I put that right there. And now we just need to do the calculation. Now in a calculation like this, you're not going to be able to do this on paper in your head because the 3/4 power of 18 just isn't going to come out right. And so a calculator is going to be really useful here. If you were to enter into a calculator 73.3 and then parentheses 18 parentheses and then the little caret symbol and then 3/4, that'll give you the answer, which is approximately 600 and something. Let's see, I think it's 640 point something. Right, and that keeps going. All right, so there's an application of the square root stuff for you. Now again, because it would be too complicated to put all these roots in a form and all the exponents with a fraction in a form, I just want you to do these in your notes. So you'll have to pause the video and work out all these problems, and I'll see you tomorrow. Thanks for watching.